much for introduction. Hi everyone, my name is Amin and I'm going to deliver my speech on big data analytics and blockchain. So let me first share my screen and then we can move forward. So
okay, please.
Okay, perfect.
Can see
Okay.
your
Okay, can you see my desktop?
Yeah. Yes, we can see.
Okay, perfect. So welcome everyone to this presentation. I'm very happy to being a part of this conference, and I'm going to talk about two important ongoing technologies, big data technologies and blockchain. And I want to give some hints, some discussion on these two new technologies to see how these are going to complete each other. So first of all, we need to understand what is big data. This is really common keyword that usually we are hearing this keyword from everywhere. This is really the industry term used with many companies, industries, researchers that they talk about big data. And unfortunately, there are many, let's say, the misunderstanding of the topic, because big data means when companies, people, researchers are facing with a new type of data, new generation of data in terms of data size. Let's say when we are talking about the petabyte size of data, the yottabyte size of data, the zettabyte size of data. So these are really huge size of data that, let's say, traditional data processing applications, they're not capable enough to deal with these amount of data. So we need to find a solution for that. And also, next to the data storage problem that we are facing with, also we need to have a new abilities for analysis at near real time. For instance, let's say when we work with small size data, when we can easily open it inside Excel, or we can easily open it in PowerPoint, we can easily open in MATLAB, any traditional data processing. We can simply run your application, your code, your algorithm, and also you can simply work with drag and drop options in these typical applications. But the problem here is because of the size that the CPU and memory, that they are not capable enough to deal with these huge amounts of data. The big question here is how we can analyze these amounts of data at near real time. Means, let's say, to analyze it in a few seconds. Let's take an example of Google. When you want to look up for a keyword in Google, so Google is going to respond your query within less than a second. So the big question here is how Google is, capable enough to respond to billions of people around the world at the same time looking for a specific keywords. So this is really, big question that we have to find how they're going to do that. So having low latency, near real time data storage, security, reliability, these are really important keywords regarding a new form of data. So having size of data is one part. So we are also facing with velocity, means the data has been generated, or let's say they are generating very quickly. Let's say Twitter, like Facebook, like Internet of Things, smart cities, they are going to generate gigabytes of data at second. So how to collect them, how to store them, how to process them, right? These are really big question. And also about, the completeness of data, also about the different type of data, like being unstructured, structure, and like having, having data in the format of a picture, video, text. These are really new form of data that we have to take them into consideration with new technology. So these are usually the challenges of big data. So how to manage and store exponential growing size of data, how to manage large volume of data, how we can collect data from different sources that coming from that they are geographically distributed, how to integrate data, how to scale up resources. Like if we have like petabyte of data, how we can configure a data center for that, and how we can have this, near real-time processing at place. And also how we can keep the cost reasonable in control, for paying for services, servers, for workstations, even for people, analyzer who wants to work with this, with this concept, and how we can expand the topic, how we can govern the topic. And the also important thing is how we can secure repositories holding the huge amount of data against malicious attackers. And these are really open challenges in big data, and there are lots of work, lots of ongoing works from academia and industry that working on, on these problems. But still, they are struggling with the solutions, to get about, let's say, to get near 100% 100% guarantee, in terms of the solutions. So let me. So the revolution is here. Exactly, there is a revolution, and we need to take into consideration this revolution. So usually we are facing with, centralized approach. This is like a telecom. So the idea is we have a server is going to, give services to different users. Let's say this service can be like YouTube, like Google, like Amazon, like, I'm just giving you the big companies. So, but this is a single point of failure for any problem came across, into this server is going to crash the whole system. So these days, this infrastructure is not really capable enough for the current and for the ongoing, requirements. So that's the reason the most companies now here in the decentralized format, like using cloud services. So where they can, distribute their services around the world, right? And there are the users. And let's say if this is the west part of the world, so people there, user there can get service from, this server that's a replication of the original one. So and the same, for the other nodes. But still, this decentralized format is facing with, a scalability problem, with security problem. So let's say if we have, this connection through, let's say for this one, and for that one, for any reason, let's say hardware failure, system failure, for anything, they're gonna be, these users around the world, they will be disconnected, through the network. And also attackers can attack to every single part of this node, because they can steal data from each copy, each replication. And there are still problems with this decentralized format. That's the reason the new revolution is gonna be distributed approach, distributed clouds, or, in a simple way, we would say blockchain. So blockchain is a technology, is a revolution trying to provide everything securely distributed. And that's the reason in this distribution format, there is no any singular failure. There is no, let's say, there is less scalability problem. There is less security problem. And that's the reason we have to take into consideration that I want to give you, a brief of this blockchain technology, how is it going on. So also this is internet history. The internet history starting from 1990. So we had web version 1 that we were working with basic HTML, email, and so on. And that one was the beginning of TCP/IP, the traditional, the internet infrastructure. And then afterwards, we moved into Web 2, that we call it information-centric, or we call it named data networking. The main reason of jumping from Web 1 to Web 2 basically was because of scalability and security. So because the big problem within any kind of network is to provide, the security guarantees. And afterwards, in 2020, that we call it Web 3, it's going to focus on decentralized and more secure, user-centric information that we call it blockchain era. So these are like, the limitation, as I said, for centralized modeling, that is going to be the today internet. And the thing is here, we want to say who to communicate with. Like me as a user wanted to communicate with you with Yahoo or Google to check, let's say, to check my emails. And also where content is actually stored. When we talk about where, means we know Google, Yahoo, these big companies, how they store data and where they store data. We can simply, get those, information. And also there are lots of limitations. And these are, these are the reasons. These limitations are the reason that says we have to move, from decentralized approach to, the next generation. That would be, decentralized modeling. So in decentralized modeling that we call named data networking, the focus is on, what to communicate. So the focus is on the content, not on the user, not on the end users. So in this case, we have to distribute, we have to distribute content across the network. And in this case, let's say this user can get access to content C, but getting access directly to this content, this machine, or even this one doesn't need to get access to that machine. Maybe he or she can get, information from this middle one. So this is the way, if you miss this machine for any reason, for any failure, maybe this is under attack, maybe this is under denial of service attack, maybe there is the power outage, maybe there is the hardware issue on this machine. So then we have still copy of C on this machine, and this machine, and so on. This is the concept of decentralized modeling. So, but there are lots of advantages on top of host-centric, means centralized one, but still there are limitations like congestion control, security, not fully guaranteed because this network still has its own, security problems, and also costly servers. We have to pay a lot to be able to, provide these services. So among these, limitation, we're still seeking for security guarantees, congestion guarantees, scalability guarantees, and let's say immutability guarantees, and so on. So to be able to handle, those limitations, blockchain is the solution. So blockchain is a system of recording information that make it impossible to anyone to be able to change or hack or cheat on information. So if you look at this one, if we call it blockchain, there are lots of, let's say criteria or advantages on top of blockchain, like it's programmable. Anyone can, anyone can design the blockchain program that we call it smart contract. So it's really secure, and that's the reason nowadays everyone talking about blockchain, because of the security, because of it's going to have tighter security. So anything is going to be encrypted within this network. This is anonymous. No one knows who is the sender, who is the receiver. That's the reason attacker cannot, put it under attack, because they don't know, what data are there and what sort of data. They can't understand which data is for bank, which data is for data center, which data is for, let's say, for a day-to-day user, and so on. So it's timestamp, means we can have transaction timestamp in the record. The most important thing is immutable, means we cannot change the data. So if there is a attacker gonna to change the data and put data integrity at risk, it's really impossible to do that. And also distributed. That's a keyword. That's the things we are looking for. So this is the whole idea of, blockchain. So if we, today we are facing with this approach that we call autonomous service provider. So let's say if Alice is going to get service from a bank, so it's going to send requests under this title bank, and these are the guys. I mean, these are the people responsible in charge of giving the response to Alice. They have to uh, go through some, let's say, process to be able to complete the action for Alice. And as you can see, we call them, there are middlemen, right? These are, I mean, who they are going to control the process, and also you have to pay them, you have to pay for charge. Also within this process, let's say if this is a data center, if you want to send a request for data center, so data center is going to get your data, you have to pay for the service, and also you have to keep your data with those providers. Means your data still is not in your hand, you have to give your data to someone else, to to a company that I mean, suddenly maybe they can decide to stop the business, and they can get your data, and you can't do anything, because this is the problem of data integrity, data confidentiality, security, availability, these are the things we have to consider. But in smart contract, we have no this problem. In smart contract, using distributed ledger technology, this ledger is the base of technology, where we have lots of nodes, right? And they are distributed. They don't know where they are, because they have been connected to the network distributedly. And Alice, let's say, wanted to get the same, service. There is no bank. He's going to send she's going to send requests under the title, we call it smart contract. And this node is going to get, the request is secure. No one can access it. No one can understand it. And they're going to process. So how to process, the request, this is what we call it consensus. So consensus is the base, let's say, is the technique, is the algorithm that can make this blockchain reliable, trustable, and also distributed. So the concept is, if we call it, I mean, if in the middle we have it as a ledger, this ledger is going to be distributed across these networks. So we call them miners, we call them nodes, right? And usually we call them miners. So miners are responsible to accept or don't accept the request, from the coming service. If a user is going to send the request to this network, so these peers should agree on, let's say, they have to agree on the contract, or let's say on the process coming from the user. So the first user receiving a request should start this agreement, and then he or she needs to send to other peers to get the agreement. If there are more than 50% agreement on the contract, on the request, then it means your request is going to be distributed, trustable, reliable, no immutable, and so on. And then your request going to be processed here. So that's the reason within this network we have different protocols: Ethereum, blockchain, ICP, Cardano, Polkadot, Solana. These are different, processing. These are different, let's say, algorithm or techniques that gonna have different consensus and also different services to end user. And that's the reason that we have to pick exactly this innovation for big data analytics. And there are two frequently used and very widely applied techniques. It's called proof of work and proof of stake. Because this consensus, right, we need to have a specific algorithm, because we need to understand, we need to know how this contribution is going to be worked. So the one algorithm called proof of work, right, this is the very well-known one, like Bitcoin using proof of work. So if you think proof of work is going to be fast, reliable, provide security guarantee, and also, as I said, should be fast enough, and you can put your services on blockchain network. If you think it's not, useful, you can work on proof of stake algorithm. So proof of stake algorithm like Ethereum, like ICP, but Ethereum is going to move to proof of stake. So they're going to, give you the other services to make them, to provide all these criteria together. So if we want to consider how is that, useful distributed modeling, so lots of advantages, that these advantages are not, supporting with centralized and decentralized modeling. So to provide trust, decentralized approach, free from censorship, tighter security, privacy, speed, visibility, immutability, guys, there are, lots of advantages through the network that we need to move forward with distributed modeling. But still, there are a few disadvantages that they're gonna be, resolved. They're gonna be mitigated, like the scalability. For instance, some networks like Bitcoin, like proof of work, is gonna to you have to pay a lot for scalability because the network infrastructure is somehow expensive to expand. Immaturity means that most countries, they don't want to accept this innovation because they say that uh, governments have no access, have no control on the process, because governments wants to have the control on everything. That's the reason the most countries, they want to ignore this technology. But since this is a technology, no one can stop technology. This is like internet 4G, 5G. Now they are expanding, like the mobile phone. Let's say 15 years ago, no one had mobile phone, and nowadays everyone has mobile phone. So because this is technology, so no one can stop technology, and that's the reason. If it's in the immaturity phase, it's gonna be uh, expanded in the near future. So energy consumption, this is another problem because it needs to get lots of graphic card, CPU to process this structure, like to calculate the ledger and the consensus. So consensus algorithm take lots of power. So and we have to provide GPU and CPU well enough for processing. Time consuming, because let's say few of them getting more time to complete the process. And legal formalities, this is the way that still people are struggling, and governments, and maybe you have heard that few countries have been accepted Bitcoin as the day-to-day currency and day-to-day technology, but few others still fighting. By the way, this is technology. As I said, no one can stop technology. So let's take few examples that how blockchain can help for big data analytics. So one of them would be proof of location. This is let's say this is a consensus algorithm. So this is really nice approach for data velocity. Means if there is a speed of data generation, for instance, for Internet of Things, for smart countries, sorry, for smart cities or smart countries. So using data analytics approach, using huge amount of data, but the data is generating at real time. So this is the nice approach that we can apply to process data at real time for those data generating at real time, right? Generating at real time, like collecting data from sensors. How to collect those data from sensors to make them trustable, secure, scalable, right? These are the three keywords that we can take advantage of this proof of location. So storage, really nice open source decentralized cloud storage. So guys, let's say nowadays we use this concept like having the cloud provider like Google Cloud, like Dropbox, OneDrive, and so on. So to use those services, you have to pay them, right? And also you have to use the applications. You have to pay for application as well. So sending data to these clouds, they want to be under attack because the way you want to send your data from your local machine to do service, there must be, huge number of attacks can be run between you and the clouds. Also, clouds, they are not really secure enough. And this is the problem. They are not scalable enough because they have to pay a lot, to expand their data center across the world. So storage is going to resolve this problem, by incorporating blockchain, here. that we call it metadisk. So in this case, everything is going to be encrypted. So your connection with metadisk is going to be encrypted, and your data is going to be distributed across the blockchain network. And no one can understand where is your data. Even yourself, you don't know where is your data, because this is the concept of distribution. And also you can try it. It's 150 gigabyte is free of storage and bandwidth. This is really cheap because for any additional terabyte, you have to pay $4 for storage and $7 for bandwidth. This is really cheap. And you can try to see how you can use it. There are different services: decentralized video storage, decentralized software distribution, decentralized backup, and so on. This is really nice, contribution from storage for big data processing when we are facing with huge data. Another innovation is Filecoin. So Filecoin is another open source decentralized storage system under blockchain concept. It's going to secure, let's say, people most important information using cryptocurrency, concept, means blockchain. So it's going to keep your data safe, secure, reliable, and also using this service want to be really, cheap. You can pay, the minimum contribution, but gets, lots of advantages on top of that. So this is also good for data variety and data volume, right? To be able to have big data analytics. Another one, Omnilytics. This is really nice one. This is for this is a blockchain-based data market for decentralized machine learning. So this is the network, distributed network, secure network under blockchain that's gonna to attract people, the model owners, the data analyzer across the world, to share their data together. And anyone connected to this network can use, other data, like let's say they can use benchmark data for processing in a secure mode. In this case, malicious data owners, they cannot get access to these data because the data have been distributed across the network. It's distributed, it's immutable, it's scalable, it's secure enough, and no one can, no one can steal your data. And I really recommend any data analyzer here working with machine learning to use this Omnilytics. This is the Ethereum-based blockchain. So this is nice for exactly the topic of big data analytics. You can get access to, to wide variety of data, talking about, data variety, data volume, the huge size of data would be here. Data veracity, we are talking about the completeness of data, and everything can be still here. And I highly recommend to go forward. And Roblex, this is another new development. This is a new generation of fintech project. So let's say traders, analyzers working with financial platform like Forex, like any financial markets, they can get this service. This is the free and open source service, and you can download it. The application called Hedge Trade, and Hedge Trade is going to connect you to the financial market in a secure way, that we call it using smart contract. And this one, also using Ethereum, proof of work, and it's going to move to proof of stake. And this is also the secure way to use, market for analysis. So can you see that? Financial market is exactly talking about data velocity, data variety, and also data volume. So also Roblex is going to, to satisfy a requirement regarding data analysis for a huge amount of data. And open challenges. And these are still open challenges, and people working on big data, scope is going to find a way to how to apply blockchain technology into the practice for big data processing. So that's the thing that still they are open, like big data architectures, frameworks, blockchain open source, talking about quality evaluation, assurance, governance, ethics, security. Guys, these are really open challenges, and I highly recommend people working in data analysis data analytics field and also blockchain to take them into consideration. And yeah, I try my best to complete my presentation, within a short time. And I'm really open for any question, anything that I can help. I would be appreciated.
Yes, thank you, Professor Amin.